So if you're here, you might have seen the actual video of me playing around on this EcoFlow powered stand-up paddleboard. But this video is more about the making of it. It's a slightly bit of disjointed footage of sort of the original testing process and the building of it, and well, just showing how it works and what's inside sort of the waterproof box. So the core principle for this project is the X-boost mode on the inverter, which is going to stop the inverter from overloading, hopefully from inrush current, and for running a slightly more powerful outboard motor. So the River Pro is 600 watt output and the outboard I've got is 625. So I'm using the X-boost mode, and the X-boost mode is a wattage limiter. I accidentally a few times referred to it as a current limiter, but it's not that. What the X-boost mode does is it drops the voltage. So it drops that 230 volt down to 90 volt, which stops the inverter overloading. And that works great on resistive elements, so like heating, and it works on motors and stuff, but it's not a fix everything. Dropping the voltage can be problematic and it can potentially damage some equipment which is looking for very particular voltage. In my case, I'm powering a power supply to power the motor, and what that is doing is the power supply I'm using can work at 230 volt or 110 volt, so the 90 volt I'm dropping it to is probably not too much of an issue for it. However, different power supplies and different bits of equipment will and won't work on the X-boost mode, so it's something to be used sparingly and understanding the sort of item you're trying to power when using it. I just want to show how X-boost sort of works. So I'm going to turn X-boost off on the app. This is a 700 watt, so 700 watt. This is 600. So if I just plug this in, if I turn on the inverter, plug this in and start the unit, this should overload the unit and turn off. So it's drawing 700 watt, 800 watt, overloaded the inverter and shuts down. So turn off the inverter, which will clear that. Now I'm going to turn X-boost back on. It's only best to power one thing at a time. This works best on hair dryers, kitchen appliances and power tools. So it's working on both inductive and resistive loads. So this is a resistive load on here. But it also might not work on some items which want very particular voltages and so on. So I'm going to turn it back on. And let's turn on the inverter again, and we'll turn on the heater. So this time, it heats straight up to 600 watt and stays there. Prevents the inverter from overloading, getting nice hot air out of it, just not at full power. So that whilst it's a 700 watt element, which is drawing 700 watt, overloads the inverter, using X-boost mode, and only allows the inverter to dish out 600 watt or around that area, which stops the unit from overloading. And also, if you wanted, you've got a very inefficient way of now heating an area. Right, so that's a resistive load, and that works on that. A more realistic real-world application could be using a heat gun. So this is a 2000 watt heat gun, and normally you wouldn't be able to use it whatsoever as it would overload it, but I can put it on the low mode, which is 1000 watts. It tried to draw that 1000 watts and then immediately went to 600, but now opposed to having no heat gun, I could have a severely underpowered heat gun, but I can still use a heat gun. Or even putting it up onto the 2000 watt mode, again, still limits it only to having 600 watts. Just in the eyes of not cheating, I am now borrowing my parents' Hoover. So the Hoover is, the Hoover is 750 watt. But more importantly, what I'm doing is, this is an inductive load. It's a motor, and when a motor starts up, it has resistance and it has a spike in amp draw. Whilst this is an AC motor and I'm using a DC motor, the same principle applies. So I've currently got X-boost mode turned off. So what should happen is when I turn the Hoover on, I'm going to get, with X-boost turned off, I'll get a spike of current, and then it should go down to its 750 watt running, and then it should overload the inverter and turn off. So let's try it. It overloads the inverter. So let's reset that. So now I'm going to turn X-boost mode back on. As opposed to that immediate straight up to max, we should see it soft starting the motor to a degree where it rises up from 3, 4, 5, 600. So you can see there's a difference on the graph where X-boost is turned off and it pulls the full amount immediately, and you can see when X-boost is turned on, it climbs far slower to its maximum. So that's the core principle of the video, using the X-boost mode on the inverter to stop overloading the inverter by, one, having a motor which is larger than the inverter's capacity, and also stop overloading the inverter with the inrush current from a starting motor. And it works, or it works so far, it seems. So now I need to find out if I can do that through a power supply, because I need to convert that AC back into DC. So let's test all that stuff. The rest of the footage is going to be a little bit disjointed. It's sort of my testing and research and development log, which sort of shows the process of how I built all the parts for this project. So first part of the project has arrived, and it's not bigger than I thought it was going to be. So for testing purposes, what I want to make sure it works. So I filled my parents' wheelie bin up with water. It's quite hard to see with the light, but it's in there at the moment. So it's got 5 forward speed settings and 3 back, and it's meant to put about 52 amp on maximum. So let's just try it out on setting 1, setting 2, setting 3, setting 4, setting 5, full beans. Okay, so that's 1 to 5. Then it's got reverse. I'm not going to do reverse because if I do reverse, it'll bend into the back wall. And for this first testing, I'm just going to use a lead acid battery, which is, well, an AGM, which is how these units are meant to be used, but that's not the point of the video. The point of the video is to do something stupid. So I do want to see what the amp readings are. So setting 1 is putting about 10 amps. Setting 2, 14. Setting 3 is 21. Setting 4 is 24. And setting 5 is 43. So whilst I am borrowing my parents' garden for this testing phase, mainly because I don't have a wheelie bin for the van to test with. So at the highest setting it was putting 42 amps, apart from the spike. However, the water's not terribly high, so there is probably a bit of air, which is probably decreasing resistance. So that means the 700 watt power supply, which is 60 amp 12 volt, should be enough. So I think I've only got a 30 amp power supply at the minute, so I think we could at least try it on setting 1 to 3, maybe even 4 on my current power supply, and see what happens. So here is the next piece of the puzzle. My power supplies. This, on the other hand, is 12 volt, 60 amp to 720 watts, I think. But I do need to do all the wiring for it. So what we've got is we've got the AC coming in, we've got the live, neutral and earth, and then you've got ground and positive coming out on the DC side. And you've got a adjustment as well, which might be quite fun to have a play with. And yeah, I'm going to parallel all of these together, well, these three together and these three together, and then onto the motor. So let's build something for this. Right, because I want to test it this afternoon because I've been patient, it's going to go wall plug, which is going to go into the EcoFlow, into some Arctic Blue 3-core into the AC slots, and then out the AC slots I'm going to use, I have no idea where this cable's come from, but it's 12 American wire gauge, which I think is about 4 mil squared in the UK standards, which is about 25 amps in open air it allows through. So I'm going to parallel 3 of them. Obviously I'm going to put connectors on the end of them. Those parallels will come together at a point which will become 10 mil cable, which will then have a Anderson connector put on the end of it like so, and then I'll put another Anderson connector onto the motor where the crocodile clips once were. Right, well here's tonight's sort of test bench wired up, plug into the EcoFlow, paralleled up wires coming to a fuse. The fuse on the negative isn't really necessary, it's just an easy way to combine all those wires. And I'm not going to put the Anderson connector on yet, I'm just going to crocodile clip to the wires. Not the best, but should be sufficient for testing. Same on that side, so let's go find the EcoFlow. Just plugged it in, all's powered on. I just changed the voltage output, so it was 12.8, which is what my other Victron one was set up. This draws a little bit more. This is drawing about 7 watt on just standby with nothing. Whilst the Victron one was probably drawing about 3 or 4. So I guess let's plug it in and see what happens. Right, chucked my hoodie over that, because in this setup it has a tendency to splash, and obviously at the minute I've not made the waterproof box. So turn it on and see what happens. So pretty similar, 11 amps being drawn, 180 watt. Let's go for setting 2. Still 10 amp. I think I did it last time. I was setting 3, it should move up again. Setting 3. 21. Again, pretty similar to what we saw last time. Setting 4. 25 amp. 400 watts are slightly higher, as last time we were seeing about 380, which this is a far cheaper power supply, so I presume it's less efficient. And 4 beams. Getting a little bit warm, unsurprising. I'll log in on the app in a minute to have a look and see what the internal temperature is doing. It's been running for a few minutes now. So I think if this is fully charged, going full power, I should be able to go full power for about an hour, just over an hour. And the power supply is still pretty cool actually. Running about 45 minutes now on max, no overheat. Still drawing pretty much the same. Yeah, it's warm air out of there, big warm air out of the fan. Yeah, power supply is pretty good. Right, down to the last 10%, we're going to turn it off. I don't need to flatten it, it doesn't prove anything. I think it's been running for about 35-40 minutes at the moment, with the inverter max out. More or less, I think the starting point was about 75. So basically, I've got what you'd expect having a 600 watt draw on a 720 watt hour battery. Right, so let's turn it off. But the advantage is I can fast charge this because EcoFlow has AC fast charging, and I believe I can charge this one at 630 watt, which means I can be back up to 80% in an hour and 100% in about an hour and a half. Right, let's see that. So a few points from the testing process is one, it was very important to test the motor in water. If you just run it in air, there's no resistance, or there's no real resistance, which means that motor only actually draws 2 amps. But when you have the resistance of being in the water, that's when it draws the higher amps. I was only seeing about 44 amps, and it's meant to be a 54 amp motor. That's probably because being in the wheelie bin, whilst there is water giving resistance, it's also circulating, which is probably decreasing resistance slightly. Another point to bring up is the power supply. So I'm using a switching power supply, and these things are usually used for like LED light drivers and stuff. So I don't know if it's really meant to be used for powering a motor. So long term, I don't know how well it will work, but it's sort of a reasonably cheap option available to me. However, what I will say is the motor doesn't work on PWM. The way this works is I believe it's some sort of resistance-based switch, which is why you've only got 5 different modes in forward and 3 in back, which seems to be kind of fine for the power supply. The other reason I've gone for a far larger power supply is I would rather that power supply was running further away than its max. If I went for a 600 watt power supply, and then if I was running at full, the power supply would be running at max, which is far more stressful on it than it is if I go for a 700 watt power supply and it's only running at 600. You know, there's a headroom. Another point is when we put it into the waterproof box, we're going to decrease the amount of cooling the unit's got. So both the power supply and the EcoFlow are air cooled, and they've both got fans built in. So we are going to get the units a bit warmer, a bit quicker. Right, so we've identified the core concept works. The EcoFlow can power a big power supply and power the outboard motor without tripping from inrush current, and even running for 45 minutes it pulled down exactly what I thought. So next is waterproofing and what we're going to attach it to. So I'm going to attach it to a standard paddleboard, and building a transom is going to be pretty easy. For those who don't know, transom is the bit the trawling motor attaches to, which is usually vertical, and there isn't a vertical option on a paddleboard, so I'm going to make one. Seems to be really simple. There's a couple of people who have done it before, and it's just going to be a long flat bit of wood with a 90-degree on it. As for waterproofing, I think I could overcomplicate this, but I'm going to go to a DIY shop, and there are a couple of waterproof, I think like IP54 rated toolboxes, which, you know, aren't too expensive. So I've got all the kit with me. I'm just going to go to a local DIY shop and basically put it all into a waterproof toolbox. And then I'm only going to really need to have probably 2 holes coming out of it, a few holes coming out of it for a gland and a safety switch. So it should remain pretty watertight. It also means it's easy to carry around and mount to the boat. That's the plan, at least. Finding a suitable box is not just being easy. Lying on its side is a potential. I don't see any reason why it can't lie on its side, and gives me access to all the buttons. And then hopefully the power supply can fit in here. It's kind of messy. So this one probably fits the best, but it is the biggest box. So the smaller one, mounted at 45 degrees, it could fit. 11th hour wildcard box. Current predicament, this one which is can be absolutely jam-packed, and this one which is a little bit bigger but quite a lot of space inside. So making them out, this box only just fits it, but I wanted to put a bit of wood in the bottom of it so I can sort of glue this down mount it and then mount the power supply to it. But when you put 18mm in here, it's too big. I've only got 18mm left, so I've routed out these grooves, then routed out the feet holes, so it sort of nicely sits now, and secured. My last few hours work. Right, almost got the box done. Just need to drill some holes in here to put the wire glands through, and it's all done. Glands added to the box. Right, done. So that goes in there. Plug that in before you put it in. Close lid. And you can plug the trawling motor in there. Right, transom. I'm going to cut the board off this line here. So this is, it's just basically going to be a plank of wood with an upright there and an upright there. Route out some little indentations just so this fits like snugly into the transom, and then probably have a ratchet strap which, I don't know, goes through these holes or something like that just to pin the box down. Might as well have the EcoFlow help power the project as well. Right, transom mount is getting there. So, little foot pedestal holes, so the toolbox that's sitting on it remains in the same spot, and it's going to get attached with these sort of straps. I just need to figure out the best way to do it. Right, that is the attachment method pretty much sorted. Just using straps. Doesn't need to be like super strong, it just needs to hold it still in the slots. So, and then when it's attached to the board, I can then have it basically going either through that way, pretty much, or through the other one. Finished transom. Just some heavy coats of yacht vinyl sherbet to give it waterproof. Holes all drilled so you can ratchet strap to the board in different ways, different angles, and also put the box on top in different ways. Little feet to hold it in, and different mounting options for the actual outboard. And that's pretty much the end of this video. So not an action-packed episode, but just sort of showing how I built and my testing process behind the EcoFlow powered paddleboard. And if you've not seen the EcoFlow powered paddleboard, go watch that video, because that's the actual fun bit of me basically having this actually working, and it worked really well. But if you've liked this sort of content or the other sort of stuff, feel free to subscribe to the channel, leave me a comment. If anyone knows about using that type of power supply with speed controllers and hub motors, leave me a message down below, because that's a project I'm thinking about for the next sort of idea or video on this. And well, yeah, thank you very much for joining me, and I'll see you next time. Cheers, bye.